there is battery inside and there is an EMF there. This is the maximum EMF, maximum energy or potential difference it can provide. Now, if you see this graph, if you notice, he says y-intercept, potential difference, and current he's plotting, and this is the maximum. See, this is the maximum. So the EMF is the maximum potential difference a battery can provide. Now, but notice one more thing. This happens when the current is zero. That means when the circuit is open, when there's no current flowing. Yes. I understand that. But the point is, you can come very close to this, and then you can extend it. Okay. Now the point is, you said how is the current zero when the potential difference? You see, it's the case where current just starts to flow. Okay, doesn't flow. I mean, just starts. It's like open circuit. I'll explain what happens. You see, it's like this. When you have a battery, it's got some terminals, it's got some chemical in between, right? And this is the maximum. It at this it's fresh. It's the maximum. If you connect a wire, the current will start flowing. But when it starts flowing, the battery itself. You see, there are some ions here, so there are some ions here, right? So they are pushing the electrons. But once they start pushing, then there will be some chemical transfer ion movement here. Now this requires some energy. So at that moment, some energy it uses itself for itself. So that is that internal resistance. So what happens is, supposing this guy can give 12 volts, okay? But he himself is using 1 volt. So he is effectively giving 11 volts outside. That's the voltage you reported. You see, some energy it uses for itself, very small amount. So the available energy outside is less. This, this is what he's saying. He's saying the total maximum is, this is for the outer, but this is for himself. Okay. Now the problem is this is not fixed. The problem is this is not fixed. This depends on the current flowing. This depends on the current flowing, and the current depends on many other factors. It depends on what is the resistance here also. Understood? So if we assume that there are two ways in which the EMF would be equal to this, if the internal resistance would be zero, but that is not the case, there is some internal resistance, and the other is if there is no current flowing. Once the current starts flowing, as you increase the current, the EMF, the potential difference you are getting, it goes on decreasing. So the energy you are getting from a battery, this is the energy, the terminal potential difference. Okay. Like supposing you have 12 here, one is used up. So 12, like 12 was here. You are effectively getting a potential difference of 11 and 0. So you're getting 11. Now you increase the current. Increase the current. You put a lesser resistance here. Okay. What will happen? You will get more current going through, more energy being wasted in. Then you will only get 10 and 0. So with each, the amount you are getting is dependent on the current which is flowing, and that is dependent on the resistance. That's why he says, if any electricity is drawn using V and I, various values of R, then the Y. So you're taking more values of R, so the I is increasing or decreasing, and correspondingly the potential difference you are getting is different. Even though the EMF is constant. Even though the EMF, the battery has a printed matter on it that this battery is able to give you 12 volts. But when you are using, you will get 11, 10, 5, 6, depending on what resistance you are using, what current is flowing, that will decide the voltage available, because current comes in the inside this. So you don't get a fixed voltage, that depends on the current flowing. So it's not the voltage. We generally think that we got a 12 volt battery, we'll get 12 volt. No, we won't get 12 volt. What we will get depends on how much current flows. That depends on how much, what resistance is in the external circuit. Okay. Now had this been Had this been zero, then it would have been very easy. It would have EMF is the potential difference. Okay, that would have been the same potential you will get always. You increase change R, you get I, you get a different I. But here it's slightly different. What you get from the battery itself changes depending on the current you are using. That is not taught in GCSEs. They don't teach you this. But now in as you go into higher class, they make you that the battery itself uses some so, and the current, the energy you're getting outside depends on the current flowing through that internal resistance. And the external current is decided by other factors also, the resistance, all that. So all of them become connected. So basically what is happening is EMF and the potential difference you are getting is now different. So that's why in that book, he said, but EMF is something different. The potential difference or the voltage you get is something different. Though in GCSE it means same. Now it's not same. So this is generally EMF is the energy for the whole circuit. They say the energy required for the whole circuit. That means within itself also, within the battery also. And potential difference is the difference in the across this. You know what is dropped. Now the other thing is very interesting is that you have to understand what's happening. Like uh, this this modeling thing. Now this is he's raising, who's doing that, the battery is doing that. Okay, that is, this is EMF minus IR from here to here, terminal potential difference. Because you can understand this by that they lift the ski lift or whatever people that thing which they take a lift. Now lift also requires some energy, no? The lift also requires some energy to move. So supposing this was the energy they are being provided, some is used by the lift itself, then they go to a higher voltage and then they drop through each resistor and lose their energy and come back to zero. But like it's like 11 volts, 0 volts here, then it becomes 11 volts and then they fall through the resistor. This is the potential difference. This is the available energy. This is the energy required by the lift itself. So you can relate it to that. Okay.